Hello everyone, today we are going to discuss our topic electrical traction. So in the traction, we are having the different types of electrifications. That is, the first is the DC system, single phase AC system and three phase AC system. Another will have the composite system. Okay, so these are the classifications, so based upon the power supply type. Okay, so another three types also there. Okay, so that is based upon the length. Okay, so length based by the distance we are having the three types. Okay, so mainline services, suburban, urban. Okay, so here the first we'll talk about the, so here just we'll have another classification, the compound system. So single phase to three phase system, or we can also call it a condo system, and another is the single phase to DC system. So here the electrification, so traction is nothing but the motor. Okay, the locomotive which will run on the electrical, so that's what calls the electric locomotive. Okay, so that will need the power supply, so that is the AC supply or DC supply, right? So based upon the supply with the classification, there is a DC system, single phase AC system, three phase AC system, and the composite system, right? So mix of the AC and DC, right? So here let's talk about the DC system. So in the DC system, the classification, so India started at the Bombay. So here the Western Railways, the Bombay's region, the Western Railway region. So that is a voltage level, so 600 volts to 3000 volts rate. Okay, so that is comes under the urban services. That is urban is nothing but, so that cities. Okay, suburban means the towns. So main lines are along the line, different lines. Okay, so here the for suburban and mainline services, the voltage levels. Okay, so 1500 volts to 3000 volts, the preference is there. So here the suburban and mainline services having the 1500 to 3000 volts is preferred. So let's take the another type. So usually, so the motors, okay, so motors used for the DC system is a DC series motor. So based upon torque speed characteristics, we prefer for the DC series motor for the DC electrification. Okay, so that is that. So the drive motor receives the power. Okay, so power receives from the motor from the power substations, that is through the poles. Okay, so overhead transmission. Okay, so in the overhead, okay, in the track we'll have the train, and the train above will have pantographs. The collections will take it from the line. Okay, depend upon the conductors. So single conductor, double conductor, or track as a return conductor. Okay, so based upon that we'll have the power supply. So power supply get from the substations. So the substations will having the classification, that is the maybe spaced. Okay, the space is that in urban station. Okay, in urban services will having the 3 to 5 kilometers, and suburban also, because in metro cities and towns will having the sum of traffic places there. So that's why we'll go for the 3 to 5 kilometers. And in coming to the main lines, so mainline services, the substations place ranges between the, that is 15 to 30 kilometers. So this advantages in the DC system having some advantages there. So first one is the DC motors, good speed control and the better torque. Okay, better torque, speed control is there, and efficient recharge rate. Okay, so braking system also one of that. So quick stop, quick start. Okay, that is another thing, right? So for the regen braking we have to use. So in the small weight per kilowatt hour. Okay, so for based upon the load side. Okay, so the advantage. And coming to this disadvantages, here the cost. Okay, so first thing is that, so this is a DC system. So DC system will needing the initial sum. So in generally in the transmission and transfer the power, that is the AC. So for DC, so we have to substation we need to require, so AC to DC conversion take place, right? So from the DC we need to convert that AC into the DC, right? So that is a cost of it. Okay, so and the higher cost of the converting, so we'll need the rectifier unit, right? So for this the cost will be high for the DC system. So negative boosters also needed for return path of the conductor. right? And now coming to the topic, that's the single phase AC system. So in the single phase AC system, the power ranges, voltage levels are having the, that is 15 kV to 25 kV. So we'll having single phase, that's 50, based upon the frequency we'll having the different types. Okay, so here the voltage level, the 15 kV to 25 kV. So and here high voltage step down, okay, low voltage of the 3000 to 400 volts for locomotive itself. So between the, in the locomotive the voltage rate, okay, this that. So here we are using AC series motor for the purpose. So in the DC we are using the DC series motor, in AC series motor. Okay, so depend upon the torque speed characteristics we are selecting the electric locomotive motor. Okay, so in the substations we'll have the ranges, the wide ranges compared to the DC system, that is the 50 to 80 kilometers, and the low prefix of the 16 to 2 by 3 or the 15. Okay, so 25 hertz free supply, that is the, so power frequency will have this on a type, another will have the other frequency. Okay, so 25 hertz. So here the low power frequency can be generated the traction system. Okay, so frequency convert along with the transformers, along with the transform will be required for power is to tapped from this existing system. Okay, so frequency convert, so we are using the frequency converter, that's also we are using cyclo converters we are using, right? So in the cyclo converts, the frequency conversion take place one frequency to another frequency. So this will be useful for the conversion of the frequency. So in the single phase A system, inversely used for the mainline services. So there is a higher kilometer, so the 50 to 80 kilometers range between the two stations. Okay, here in another type, the composite system. So in the composite system, that's so called the single phase to three phase system or condo system. So single phase to DC system. Okay, that's the composite, so mixing of AC and the DC, or single phase to three phase. Here the condo system, the single phase to three phase, so it's developed the in the year 1993 in Hungary. So here the single phase overhead supplies, that is 15 kV, and power frequency, that the 50 Hz frequency, and the brake converters employed the locomotive to convert single phase to, okay, a phase converter is employed. Okay, phase conversion take places here, the single phase to three phase supply at relatively low frequency. So here, so we have three phase induction motor. Okay, so in the locomotive we are using the three phase induction motors for developing the required power driving motor. Okay, so this is made the complicated three phase overhead. So because while traction, okay, so we collection taken, so it is only possible for easy for possible to collecting the power from single line. Okay, if it is three lines are placed at the overhead, so what will happen, the collection is not possible. Okay, so complication will take place. So that's why using the single wire, and that will convert in the three phases. So with the development of semiconductor technology, so it is possible to obtain the frequencies so low as well, that is the off hertz. Okay, 0.0 hertz, that is will hang the nowadays the depend upon the low frequency level. Okay, so here the frequency conversion eliminates the drawbacks of three phase induction. So some of the frequency, so will have some losses also there based upon the frequency, so that will be eliminated by decreasing the frequency level in the three phase induction motor. Okay, so low frequency the induction will develop the high starting torque. Okay, so here that is the, so why we are going for lesser frequency means the torque there is, so torque generation is high starting torque without, okay, without drawing excessive current from the supply. So with less amount of power you can generate the high starting torque. Okay, that will be is possible for the low frequency. So that's why we are using the frequency converters, that is the 25 Hz to 11 kV, 15 kV, 15 kV to 25 kV. So the speed control is continuously obtained the varying the supply frequency. Here the single phase to DC system. So here the system adopt the simple single phase one wire system. So overhead equipment, that is a 25 kV at power frequency, that is the power frequency number 50 Hz supply, and single phase this supply is taken stepped down and converted into DC in the locomotive. So in the overhead 25 kV voltage is flowed, and at the frequency of 50 hertz, and that is converted in the locomotive, okay, to into the DC. Okay, DC series motors used to obtain the necessary torque. So here in this type, so one only wire is placed at the top of the overhead, and conversions take place in the DC. So that's a converted into DC in the locomotive. Okay, that's one thing. So here the motor which we are using, that is a DC series motor. So here advantages. So some of the advantages are there: single phase AC to single phase, sorry, DC overhead line. Okay, so here the as the system voltage is high, uh, the required line, okay, so required current will be less for the given demand. Okay, so the single phase, okay, advantage single phase AC to DC. Okay, that's another, and also reduce the cross section. Okay, so reduce the cross section of overhead conductor and supporting structure. Okay, so H type to T type, L type. Okay, so due to the high voltage, the substation can be spaced at a longer distance, so 50 to 80. So in case of DC, we have to place the distance, that's the 5 kilometers to 8 kilometers in urban. Okay, that is another. Okay, so the cost also will be reduced in case of AC. So the power can be tapped. Okay, so the that is power can be tapped. The power frequency that is normally with the gen transformers. Okay, so transmission will have the 50 hertz supply, right? 50 hertz frequency, so that will easily tap from the grid. Okay, and high coefficient adherence is obtained order of 45 percentage. That is another advantage of the single phase system, and this increases the power at the increase the power to weight ratio due to the elimination of starting rest. So that is the another thing. So in the starting resistors we are using the DC system. In coming to the AC, we are not using the starting resistors, and is starting the reduced voltage achieved by untapping charge. Okay, so by using the tap changes, we are reducing the voltage also at the starting, because high starting, so low starting. So it is installed the both primary and second of the transformer. So advantage. Okay, so advantages are there. So there is a clean and neat compared to the cold traction system. So in the here the electric motors have starting torque and the range. Okay, so 1.5 to 2.5 kilometer per hours in electric motors. So in coming to the 0.6 to 0. In steam engine. Okay, that's the difference. Okay, so we can easily see in the steam engines the speed. Okay, so does not require the water. Okay, so in electric motor it does not require the water. Okay, to start. Okay, so in the steam engines the water and coal required, and nowadays we are using the diesel engine. So that is also on that. So diesel engine runs on the petroleum products. Okay, so here the well suited for the underground and tube railways. So this will very suitable for the underground and tube railways, and the maintenance cost and time also require less, and regenerative is possible. Okay, so save the high grade coal. So in the steam engines require the generate the steam, so require the coal, right? So that will be eliminated here. Okay, so most technically for high traffic density, so we can easily place for underground tubes. That's another, that's the economic cost. Okay, so here the electric braking is superior, so mechanical brake. So electric locomotive is able to negotiate the curves at higher speed. So that's when coming to the steam curves. Okay, that will be eliminated. Okay, so electric motors act with very less area compared to the steam. Okay, uniform torque. Okay, and electric motor reduces the jerking action of the passengers. Okay, so in steam engines, so we can easily check the, so while sudden brakes is applied. Okay, so the falling will take place, right? That is not done in the electric traction due to the braking. Okay, so some of the disadvantages, that is the initial, so overhead lines, and another is the power failure. So if it is power is failure, so total entire system is not work. Okay, that's another thing. Okay, so additional equipment required for the regeneration, and communication lines or experience interface with the power. So that is the other disadvantage. Okay, due to the electric traction. So this disadvantage we can observe in the easily at the outside. but moreover the disadvantages having more advantages compared to the steam engines. Okay, that's where more possibility are there. Okay, so we are going for the AC system. Okay, so this is about the electric traction. Okay, thank you.